Vamos a dar paso ahora a la tercera sesión, que bajo el nombre de...
Now we have the third session of the morning under the name of BIM Investigation, and what we are trying to do is bringing different voices of different investigations are being carried out right now regarding sustainability and other topics always related to BIM. The first member will be Antoni Fonseca from the research group NECADA. Good morning, everyone. My name is Antoni Fonseca. I have a PhD in Optimization and Sustainability Systems, and I am here representing the Bio Research UPC group, and we have created a spin-off, and we are focusing on sustainability topics and BIM. This spin-off is basically focused on developing the NECADA software. So we basically focus in two aspects. We look for the BIM, the Building Information Modeling, that we understand is the best methodology in order to process all the data and information in the same file. And then we also worked around sustainability. And this is key nowadays in order to develop every project. Currently in Spain, BIM and sustainability are starting their journey within the EU BIM guidelines. There's only one EU BIM guideline about energy efficiency, but they don't really talk about sustainability. We are one step further, and what we propose is an optimization software, the NECADA system, so that we basically think of an cloud optimization by using advanced optimization systems. And the idea is to use the European sustainability regulation, which is already published and is already active. And then we want also to do the analysis of the model with the complete life cycle using the ICF system and using advanced optimization systems. As we know, BIM includes all the information of the building. Right now we are analyzing the energy efficiency report, but where is the place or where is sustainability? Well, we include that in the sustainability regulation. And then there are also some energy certifications, as we know, LEED, BRIA, BELDE, which are international and also work in this area. When we create a BIM model, we actually use a lot of time and energy so that the model contains all the information and complies with all the expectations. In order to do an optimization analysis, what we do is we do specific analysis, and then maybe we do 10, 15, 20 cases based on our model. With our software, what we want to do is doing it out in an automatic way and being able to do thousands of these analyses. We've done 30,000, 60,000 simulations in some cases, as we will see. So basically, we use BIM and sustainability together. We are based in the European regulation that is already published. The Spanish regulation would be the one of environmental framework 15643-1, 15643-2, 3, and 4. So basically, we want to do this optimization analysis in each stage of the life cycle of the building. In the 4 stages, in stage A of the product, B, the use, C, life cycle, and D, benefits. Normally, in buildings, we are already generating different systems. Then basically, we also focus on the amount of software that should be used in order to have this optimization we are aiming for. The NECADA software is not based in just one program. or for thermodynamic calculus or energy efficiency. For example, those would be Energy Plus, Transys, and so on. So NECADA is a co-simulator that is a system, a methodology that allows us to join the different softwares. It doesn't matter if they are thermodynamic software or computational fluid dynamics software, or maybe it's more of an analysis software, or lighting software, water, or acoustic systems. It doesn't matter. So NECADA has two versions. It has the cloud version and the desktop version. For the desktop, you actually need to have some programming knowledge. That's the one we use in our research group. And the cloud version is open to users, and that is actually a very direct system so that optimization can be achieved. Here we have NECADA, is this website, necada.com. And the idea is that the user can log in here and then use the BIM model at its full potential and do the optimization process considering sustainability based on three pillars, which is environmental, economical, and social. So here we have this idea map. We have transformed that into programming, and we are basically focused on the building, which is the most important part in NECADA. We can have the optimization here, going from design through construction, life cycle, and construction. Then we also have the waste development part and compensation. Of course, we also need some data input. That would be the weather climate files. And we also have another block, which is the climate data, where we can analyze the climate change analysis. Many times simulation programs are based in just one software. For example, Energy Plus do the analysis, the energy analysis on a yearly basis, and then that needs to be applied for the next 30 years. If we have the weather data files for the present and the future, with NECADA we can do the optimization for 20-30 years. So starting here, we need the information about the building. We would have the BIM here, the ICF, or the specific file that the team will have. And then we would also have the permutation file. That's for the cloud system. And this is for the... This is not a problem for the user, because this is a website that is actually really easy to apply. Relating database, this is key. In order to do all the environmental and sustainability analysis, we need to have all the materials and their data. So we basically work with different international databases, with the ITEC, EcoInvent, the different open databases, or different dApps from different companies. The data we can collect from this optimization is the data that the regulation defines. We talk about all the weather data, social data, and economical data. So basically, we can collect all this information if we have the right database where we have incorporated all the data, all the information. You know that in order to do a sustainability analysis, the complexity comes because it's very difficult to find the impact, the environmental impact data for some materials, for example. So when we talk about optimization, we don't talk about doing simulations for strength. We talk about optimization algorithms. We have applied this in engineering for a long time. There are different optimization algorithms that improve the speed and the performance of the process. And with NECADA, for example, we can use the ones on screen. And because this is a research program, that allows the user in the desktop version to include their own optimization algorithm. In any case, if the user is not an expert in these algorithms, the web version actually suggests some versions so that they can guide the user and the user can see what is the right algorithm to use. So here, for example, we see an example of a passive house that we actually did some years ago. We wanted to do an optimization simulation, and all these points we see here are simulations, and what we optimized here was the insulation. It was a research project, and we wanted to specify what was the insulation width for these. And this could be an example of what we can do with Necada. When you go into the website, that's the dashboard, the general dashboard. Well, we need to obviously input some information so that we can do the optimization simulation. We have the material information. We also need to put some constructing solution information and also the building models. We also need to introduce the sustainability data, all the impacts regarding economy and environment. We would go to the project, and then afterwards we would go to the process where we generate the optimization map. It would be nice to see how we apply it, but that's the idea. So once you're here, you tell the software, for example, that at passive system levels, what kind of solutions you want to optimize for the windows, for the facades of the building, and the same with the active system. This way, the software creates all the map and does the optimization itself. In order to upload the building models, we can do it in different ways. We can do it in a BIM format, but we also have another possibility. In this case, if we look at a very simple information sheet, we can generate our BIM with the Spanish cadastre information. We can do that for urban simulations or also for those technicians that want to have an approximation and they don't want to spend time on constructing their own BIM model. So they can use this application, and this is quite interesting because it's a very powerful application. With weather data, what happens? Well, we need to upload the weather data files. We can do some analysis here of the weather files from the past, from the present, and also for the future. This is a very interactive map, and the user can upload their own files here, or also they can choose public files. They can use public files from the US Energy Department, for example. This could be an example of a project where we worked together with Acciona. And as you can see here, when you use very powerful software, allows us to actually see different scenarios, many different scenarios, because we want to choose the optimal one. With Necada, we work with language R, which can be exported to different formats, and that allows us to have a statistical analysis that is very powerful. This graphic is interactive. You can actually turn it around and so on. And then here we have an example of another analysis regarding the environmental impact and also the economic impact. Here we see some indicators that we were able to gather after doing the optimization. Here in this example, we compare different things, and we developed this model together with the university. Here we had this optimization. The red dots here are the optimization systems through the hill climbing algorithm, and the green ones are another kind of algorithm. Using the hill climbing algorithm, we saved 80% of computational energy and time. So that's very interesting for projects. For example, here, in this project, this is very interesting. We worked together with the Energy Research of Catalonia, the IDEC, and here we had quite many more simulations, about 60,000. Here we work with Transys, which is another energy software. We did that in the desktop version. The team was very active in this project, and we had a double simulation. We had passive simulation and active simulation, and the results were very interesting because we actually got some very interesting results, and we were able to reach the typology we were studying, and we went from a D certification to a B or A certification depending on the situation. Here we have the summary of this presentation, and here we have we can see how the co-simulation Necada software can introduce all this data so that we can apply it to different things. This is a software we work with at the university, and it's open to the public right now. Thank you very much for your attention, and that's pretty much on my side.
Muchísimas gracias, Antoni. Y ahora...
Well, thank you very much, Antoni. And we've seen some research on sustainability, and now we are going to see research applied on infrastructure. Therefore, we have Miguel Pretio. He's a lecturer at IARO, and he's responsible for infrastructure.
Bon dia.
Good morning. First of all, please apologize for my voice, but I'm suffering from an allergy, and this affects my voice. When I was asked to come here and present on BIM and research at our company, we believe it was interesting to show you the case of internal research on how to implement BIM in the infrastructure sector. I think that's nothing new. The BIM methodology was boosted, especially in the building field, but now we are in need to implement. When we talk about infrastructure, the problem is larger or bigger for the reasons I'm going to explain next. I would like to add that one of the great examples of how to work with BIMs is our company, because we share the structure among different companies. We manage 1,300 employees around the world in 90 offices, and that's quite a great effort. The first point I wanted to highlight is that when we internally started to review the words that to us defined the path we wanted to go through, we did a quite creative exercise, and the final result were that the works, data, digital, life cycle, and collaborative were the most relevant terms. I would also like to say that the research in Arup, our company, first is asked to measure all the processes. We have an online tool which is open and free to use at our website if you are interested. And to us, it's really important to assess our procedures to see what's being done well and wrong. I don't have time to explain how this tool works. If you are interested, maybe afterwards we can have a quick chat on that and see how it works. So, moving on, I'm going to talk about the differences between BIM and building, BIM and infrastructure. What you can see here is a map of the City of London. The first project that we dealt with at Arup was the Crossrail, the first project regarding BIM. As you know, the London Tube has been collapsed or overused for a lot of time now. And the first project that we completely prepared in BIM, also required by the UK authorities, was a tunnel that would go across the city. That supposed a radical change regarding the technology that we were using before. In the first place, because of the magnitude of this project, which included many kilometers of tunnels, a lot of interaction with the affected services in the city, and so on. Then we don't have any standards, so that's a major issue. And within the Building Smart, there are many work groups who are doing some research on the IFCs to apply them to different infrastructures. But the reality we have, and especially when we started with this project, is that there were absolutely no standards. Finally, the software, which was an issue as well. When we talk about building, I would say that everything is much well defined, because a road is quite differently from a railway or a dam, but that was a big challenge. As you can see here, that's nothing new. The first or the main issue we have is the only IFC that we have for infrastructure is the one for traceability or tracing. And it doesn't solve you all the problems, right? At the end, what you have, it's a transfer of the traces, but you cannot work with sections or not, so it's only partially useful. How do we work? We use, or we actually think about stuff quite a lot, and we try to adapt the software and programs that we already use, and we try to include other software such as XML, AHP, and Excel, which continues to be a fundamental tool for our work. You can see here an overview, not a full overview, but quite significant, of all the things we have to use when handling with infrastructural projects. That would be a classification, conceptual classification from design up to fabrication, production, coordination, analysis, and collaboration. That's what we face in our daily lives, and in, I would say, almost all large infrastructure projects that we carry out. When we talk about complex projects, such as the ones we have already seen and the one I'm going to present you right now, that's how it works. What do we do, or how do we work? We exchange information through Land XML, but we can only dump or transfer this information for tracing. And at our office in Madrid, we are designing the tendering offer, the bidding offer for the Canal of Panama. And the issues we are encountering is that there are many companies. We have to adapt to what the client expects. In this case, is a Ministry of Public Works of Panama, and basically there's a long way to go. And I would, both to Building Smart and all the people working in this community, what I want, the message I would like to say is that a big effort must be done. The calculation of networks. Here we have our very own model. We developed it internally at Arup. We use with the models that we usually work, SU, AutoCAD, and so on. And we are happy with it because it allows us to link all the calculations we do for any kind of network, and we link this information with the design model. Also, the changes and modifications are automatically translated or transferred to the design model. Having said that, we had to do a little trick. You can see that between the four models, we have this Excel sheet with a very simple script that allows us to go from the calculations to the model. So a little bit the same as I was saying. We don't have very much problems. Geotechnicals is a very specific field. It's a field that works with digital formats because it handles a great amount of information, and geotechnics require a lot of sondages and etc. And I'm going to go over this quite quickly because I'm running out of time. GIS. Well, we want to skip actually this transition from GIS to BIM and back to GIS because for us it's a continuous line. We use GIS at the beginning, then we move on to BIM, and then we go back to GIS. I'm going to skip all the videos. That here is a model also developed by us. I'm going to skip all the videos. I apologize, but our presentation time has been cut. That's a very interesting project as well. I'm sure you know about the CIRN, the research center in Geneva. As you know, the synchrotrons are in that tunnels. And when the new tunnel was being built, Arup was commissioned with the layout of the new tunnel, and we won an internal award for the best digital design or conception. We managed to put all the information in an online tool that the geotechnical engineers could use, and all the maintenance, servicing and communication data would be linked to the geotechnical specifics. Finally, that's a plant of solids. That's a project developed by our office at Arup in Madrid for sea engineering. And we applied a BIM methodology. We developed everything from the structure, the docks, the earth movements, all the water networks under this plant, the conveyors and transporters, everything. We developed an internal model with a budget within the company, and the result was quite a curious model that precisely yesterday at the port or the hub conferences held yesterday in Alicante, we presented it. It was presented and it was quite a success. I just wanted to show you to see how useful how useful BIM is, not only in the developing, but also in the operation. Here we can see if the crane, or how the crane fits with the boat or the ship. That would be it. I would like to thank the organizers for allowing us to be here and to give you this takeaway. That's continuous work, and there's still a long way to go. Thank you very much.
In the meantime, I want to say something. We are having some technical and technological workshops in room 5.2 and 5.3 during all the morning, and we can all access those rooms to see the presentations that they are doing there, so that you know. Now we have Rubén Duarte Díaz da Costa. You can tell by his name that he comes from Portugal, and he belongs to the Greece group, and he will show us a couple projects, Fitman and Optimum. This is basically BIM research based on transportation and industrial technology.
Okay, good morning. Thank you very much for attending. So I'll just give an outline of what it's supposed to be presented here. So basically I'm going to just spend a few minutes in describing our institute, where we came from, basically our research areas, and then going a little bit into the topic of today, which is, first of all, interoperability, which is something that was already discussed during this morning. What about the IoT? It's actually a trend, actually a jargon that it's being talked over and over, especially on research domain. So we'll try to demystify a little bit of what is IoT and what could be the benefits of IoT to the construction industry. And then I will basically refer to European research projects that we are engaged with. So just a little bit background of myself. So I'm a senior research at Uninova Institute. So basically, Uninova Institute, it's based inside the University of Lisbon campus. And we are a small, I would say, a small group of researchers that basically do research in interoperability, okay? So basically, interoperability, it's our, I would say, domain of speciality. Of course, that we have inside interoperability, which is a large domain. We have several subdomains. One is dealing with, let's call it, semantic interoperability. So it's not basically interoperability on data sharing, but actually to give meaning on the data that it's being shared. So this is one of our domain topics. It's on semantic interoperability. The other one, it's more focusing on how we can get this interoperability to be more sustainable. So we discussed it during this morning about models, about BIM models, which refer to some rules. But of course, these models are not static, okay? The idea is that these models are dynamic, and at some point, interoperability, the way we process these models, must also be dynamic. So there is a way that we need to make this interoperability sustainable. Other domain of research, it's focusing more on the hardware stuff, more on the sensing capability, something that it's called also cyber-physical systems, which is a term that it's not really actually applied into the construction domain, but more into the manufacturing domain. And as a last topic, one of the biggest trends right now, and something that the Commission is putting also lots of money in it, it's on big data analytics. So about interoperability, and actually by the end of the last session, there was a lady here that raised a question, and basically the question was, well, I have several programs and I want to exchange data between these programs, and what I see is that every time I exchange this data and I open in a new program, data is lost, okay? So why is this data is lost? Because lacks of interoperability. So it means that if programs use the IFC model, for instance, which is a standard in order to exchange building and construction data, it means that the programs are not 100% interoperable. Maybe there are ones that are 80%, 90%, but I'm pretty sure that most of the problems are not 100% interoperable. And this is a biggest research area, which actually the group where I'm working on it spend basically our time, okay? Just giving this definition about interoperability, it's basically the idea is that two systems or more systems, they can exchange data. This data can be processed, but not only in process, but also be interpreted by these two systems. We can talk of systems, but of course we can talk at a more wider level, at the enterprise level. And collaboration is also one of the topics that was discussed here. So in order to have collaboration between companies, we need to make sure that companies are interoperable, okay? So this is also very nice. We live in a world that it's supposed to be interoperable, but in order to get this interoperability, the first thing it's about the data itself. We need to make sure that we are really collecting data, and this data it's reliable, which is most of the cases is not accurate. So if we are relying on, for instance, sensor technology, there are several problems. Sensor breaks down, there is a power failure. So it means that we need to make sure that we are really acquiring the data, and this data it's in a quality or in a maturity state enough that can be processed. And this leads me down into, I would say, a more bottom layer, which we call the IoT, okay? It's called the Internet of Things. The idea that I want to state it here, there is this important need in order to sense the environment, to see what is happening, so in order that we can process this data and to act. So we have two meanings here. So in one hand side, we have the sensing capability to understand the environment, to have basically contextual knowledge about the environment. And on the other side, we have the capacity or the ability to act upon this environment. So sensing and actuating. And this boils down into the notion of the sensing enterprise. Okay, so sensing enterprise, it's also one of the terms that it's now being pushed more and more by the European Commission. There are lots of open calls that are focusing on this term, on the sensing enterprise. So we live in a world that we have the digital enterprise. So basically everything is done digitally. We have digital models, like for example the BIMs. We use these models in order to promote collaboration. But I think that we can go a little bit further than that. I think we can go into this notion of the sensing enterprise. So it's not really to have a model that expresses data, but also have a model that can actually, in real time, being able to integrate this data that is being collected by, for instance, different sectors, sensors that we could have in the building. So I think that the leap here, the challenge is actually how can we basically not have a model that it's, I would say, static or it's reactive, but going a little bit further than that and going to have something that it's more proactive, okay? We can have early detection of events before, for instance, problems occur. And this is where we want to go. So, as a conclusion, it's basically to integrate what we have already in the data, in our data from the buildings, also with real-time data that it's being generated in every second or in every millisecond, new data is being generated, and how can we actually integrate all these two domains. Okay, this is a more or less common sense, what is basically the motivation behind that. I would like to remind you that I would say that the roots of the sensing enterprise came not from the construction industry, but more into the manufacturing industry. And actually, in one of our presenters in this morning, Bimal mentioned about actually the construction sector to be more and more automatized. So actually, manufacturing and the construction sector also have lots of points in common. So the idea is that why can we use some of the paradigms, some of the works that are already being addressed in the manufacturing industry, and why not bringing those concepts and apply them into the construction industry? Those are I would say, two phrases that were stated by General Santucci and Cristina Martinez and Diana from the European Commission, which basically said or state basically this. So the idea is that all the models and all the enterprise models needs to integrate the notion of the sensing capabilities, okay? Intelligent sensing. Once again, to recap, on having in one side the digital models, but on the other hand side have the ability to collect data from the environment. And here on this slide, we have basically an example. On the lower hand side, we have a shop floor, a manufacturing shop floor, with human production. And then on the upper, we have the digital, basically the digital models. The idea here is that we can actually integrate these digital models with actually data that it's being created in real time on the shop floor, okay, where actually the things are being made. And here on the middle, we have a picture of actually a worker with sensors on the arms. And basically the idea here is that we are actually collecting the movements of this worker and to combine with the production models of the factory, of the plant. Basically, once again, it's actually to integrate more and more the notion of the human and the machine. Okay, just a brief recap of some of our European research projects that we are working on. I will spend just a couple of minutes more on explaining the Optimum project and the Fitment project. So basically, the Optimum project, it's a project that it's focusing more on the transportation and the mobility sector, which is once again a highly data-intensive sector. And just to highlight the notion of, once again, we have to have sensing capabilities in order to extract meaningful information in order to make proactive decisions. This project, it's divided in 3 different pilot cases. So one, it's what we call this proactive improvement of transport systems. The idea here is to have more personalized service to the users, take into account, I would say, the status of the traffic in real time, and also the behavior or the profile of each user. And by combining this data, we can have proactive services, proactive notifications to users. The second pilot is what we call this dynamic tool pricing. This is a pilot that we are deeply involved in because it's a pilot that it's being run in Portugal. What happened in Portugal is that we have lots of highways. Most of them are new. But since we have tolls on these highways, it means that nobody uses it. So the highways are, I would say, pretty much empty. And this caused a big problem because the government made a big investment on these highways and it's not getting the return on this investment. So one of the ideas is actually to sense, once again, to sense the traffic on national roads and to detect situations where congestion or traffic jams are appearing, and to lower, in a dynamic level, to lower the prices of the tools, so in order to deviate the traffic from the national roads into the highways, okay? So once again, we have sensing capabilities in real time in order to make decisions, once again, in real time. Pilot 3, which also it's one of the pilots to be addressed within Optimum project, it's basically focusing on interaction between cars and the environments and communication between cars and other cars. I will not spend too much time on this. Just to give you a brief overview about the architecture, our conceptual architecture, once again, we are relying on big data. So take into account there are millions of sensors that are acquiring data in real time. So it means that we have computational power big enough to process all of this data. These are some examples where we are basically to process the data. We can look, for instance, into Twitter. Twitter can be seen as a virtual sensor, and the idea is that we are processing messages from tweets in order to detect peaks of traffic jams. Okay, so as we can see in these red circles, it means that we have 2 peaks during the day. It means that the first peak is during the morning when people go to work, and then we have another peak when people are returning from the work to home. This is something that it's automatically detected in real time using tweet messages. Another idea or another work that it's being addressed in Optim, it's actually to detect personal mobility patterns. So it means that each individual have their own mobility plan, and the idea is that we can learn these mobility habits or these mobility behaviors from users, and to basically to forecast or to predict what it's going to be the movement of this user in the future, just in case there is a traffic jam, there is a congestion, there is an event, in order to basically to alert this user to take a different route, for example. I will not spend too much time on this complex event processing. This is another way in order to basically detect what we call complex events in real time, and I will spend just one more minute on describing this Fitman, which is another project that we are involved in. So Fitman, it's a large project. It has 10 different pilot case scenarios dealing with automotive, aeronautics, textile, plastic, and there is actually one of the use cases that it's dealing with the construction. It's also, the pilot case deals with the construction of a dam in Portugal that it's being addressed by Consugal. And basically the idea is to have RFID readers in order to track and trace products that are being moved from place to another inside the construction site. I don't know if I still have time just to show a small video. Well, maybe not. The video was supposed to be running, but okay. Thank you very much.